This video is a walkthrough of the November 2017 Higher Tier Paper 3 Calculator. Question 1. So we've got a table that shows information about the heights of 80 children. So we've got 80 children and we've got their heights in groups. So we've got all the different information here, and it says find the class interval that contains the median. So imagine we've got 80 children all lined up in height order. We want the middle one. So we want the 40th, or in between the 40th and 41st child. So we need to work out how far along the line is the 40th or 40.5th child. So we've got 4 between 130 and 140, and then another 11 between 140 to 150. So we're up to 15 children now. And then we've got another 24 between 150 and 160. So that's 39. So we've got 39 children up to 160. So the 40th child must be in the next group, because there's another 22 in there. So the class interval that contains the median is 160 to 170. Part B, draw a frequency polygon for the information in the table. So with a frequency polygon, we plot the midpoint against the frequency. So midpoint for 130 to 140, halfway between 130 and 140 is 135. Halfway between 140 and 150, 145. And then we have 155, 165, and 175. So we're plotting midpoint against frequency. So 135 against 4. 145, 11. 155, 24. 165, 22. And 175, 19. So we've got the points, and then we're going to connect them up with straight lines using the ruler. So straight lines to connect all of the points we've plotted. And that is our frequency polygon. Question 2. In London, 1 litre of petrol costs 108.9p. In New York, a gallon of petrol, 1 US gallon of petrol, costs $2.83. So we've got a conversion, $1 US, 1 US gallon is 3.785 litres, and £1 is $1.46. So we need to make them the same to compare them. And the question is, which is better value for money? So which is cheaper? So if we change the New York into pounds, so we're going to change New York. So at the moment we've got 1 US gallon equals $2.83. So let's change US gallons into litres. So 1 US gallon is 3.785 litres. So 3.785 litres is $2.83. Now I want to find out how much 1 litre costs. So I'm going to divide by 3.785. Divide 3.785, and that will give me the cost of 1 litre. So in the calculator, 2.83 divide 3.785, and still in dollars, so $0.75 to 2 decimal places, but keep the whole number in the calculator because you're going to use it again. So I've rounded it here, but I'm not going to use the rounded number, I'm going to use the whole number. So 1 litre is 75 cents. So now I need to change 75 cents into pounds. So 75 cents, or the whole number, so I'm going to use the answer button on the calculator. 75 cents. And I'm changing it to pounds. To go from pounds to dollars, I times by 1.46. 1 pound is 1.46. If I want to change dollars to pounds, I divide by 1.46. So changing dollars to pounds, dividing by the exchange rate. So the whole answer, divide 1.46. And that gives me 51p. So 51p. So 1 litre in New York is 51p. So in New York, a litre of petrol is 51p. In London, it's 108.9p. So our conclusion is New York is cheaper, is better value for money. Question 3. A gold bar has a mass of 12.5 kilograms. The density of gold is 19.3 grams per centimeter cubed. Work out the volume of the gold bar to 3 significant figures. So we've got different units here we need to make sure we've noticed. So we've got kilograms and we've got grams. So if we change kilograms into grams, that means times them by 1,000. A kilogram is 1,000 grams. So 12,500 grams. And it's a density question. So density equals mass over volume. Density equals mass over volume. What are we working out? We're working out volume. So that's going to be mass over density. The mass is 12,500. The density is 19.3. They are in the correct units. So we're just going to type it into the calculator. And we get an answer out of 647.668 and so on. We want 3 significant figures. So that's 648. So 648 centimeters cubed. Question 4. There are only blue pens, green pens and red pens in a box. The ratio of blue pens to the number of green pens is 2 to 5. And the ratio of green pens to red pens is 4 to 1. So we've got 2 ratios here we're going to put together. And then the question says, there are less than 100 pens in the box. What's the biggest number, the greatest number possible of red pens in the box? So let's deal with putting these ratios together. So we've got blue to green, 2 to 5. And we've got green to red, 4 to 1. So we've got green in both the ratios, so we need to make the greens the same. So we're going to times this ratio, times it by 4. And we'll take this ratio and times it by 5. And then we'll make the greens the same. The greens will both be 20. So timesing this ratio by 4, 2 4s are 8, 5 4s are 20. timesing the green to red ratio by 5. 4 5s are 20, and 1 5 is 5. So now we can put the two ratios together. Blue to green to red is 8 to 20 to 5. So that's the ratio, and that's in its simplest form. We can't simplify these anymore. And there are 28, 33. So 8 plus 20 plus 5, 33 parts. So there could be 8 blue pens, 20 green pens, and 5 red pens, or any multiple of this. So there could be 16, 40, and 10, and so on. It says there are less than 100 pens in the box. So, well, we could either have 8, 20, and 5. We could have 16, 40, and 10. Or we could times it by 3 and have 24, 60, and 15. So this will be 66 pens. This will be 99 pens. So they're the only options. We can either have 8, 20, and 5, 16, 40, and 10, or 24, 60, and 15. So they're the only options. There are less than 100 pens. That's why they're the only options. What's the greatest number of red pens? That must be 15. So 15 is the answer. Question 5. Find the value of the reciprocal of 1.6. So reciprocal means 1 divided by. So 1 over 1.6. So 1 over 1.6 is the reciprocal of 1.6. So type it into the calculator. It comes up with 5/8. The question says give your answer as a decimal. So press the button on the calculator that changes it to a decimal, and we should get 0.625. Part B. Jess rounds a number x to 1 decimal place. The result is 9.8. Write down the error interval for x. So we've got 9.8 to 1 decimal place. The one below is 9.7. The one above is 9.9. So if we've rounded it to 9.8, we look halfway between 9.7 and 9.8, 9.75, halfway between 9.8 and 9.9, 9.85, and they're the two bounds. So it's going to be bigger than 9.75, less than 9.85. So it's got to be in between 9.75 and 9.85 to round to 9.8. It can equal 9.75, but it can't equal 9.85. So we put an or equal sign for 9.75, but just a x is less than sign for 9.85. Question 6. Here is a rectangle. The length of the rectangle is 7 centimeters longer than the width of the rectangle. 4 of these rectangles are used to make an 8-sided shape. The perimeter of the shape is 70 centimeters. Work out the area. So the length is 7 longer than the width. So if this is x, the width is x, the length is 7 more, so x plus 7. So let's draw on the perimeter. So we've got x, x plus 7, x, x plus 7, x, x plus 7, x, and x plus 7. See, there's 2 parts we haven't got something written down for. So here and here. So how long are they? So we've got x plus 7 all the way along. this part, the green part I've just drawn is x. So if this is x, the whole way is x plus 7. That red part must be 7. So this is x. This green part is x. The whole way along is x plus 7. So the red part must be 7. So we've got something all around the perimeter. So we need to add up the perimeter and make it equal to 70. So we've got 1, 2, 3, 4, 5, 6, 7, 8 x's. And we have 1, 2, 3, 4, 5, 6 sevens. 1, 2, 3, 4, 5, 6 sevens. And that equals 70. So 8 x's plus 6 sevens, that's the perimeter, and it equals 70. So 6 times 7 is 42. Now we've got to solve the equation, so subtract 42 from both sides. 8x equals 28, and then divide both sides by 8, so 28 over 8 is 7 over 2, or 3.5. So x is 3.5. There's a rectangle. X is 3.5. The length is x plus 7, so that must be 10.5. So x is 3.5. X plus 7 is 10.5. I'm actually going to redraw that. So the area of a rectangle is 3.5 times 10.5. 3.5 times 10.5. Type it in the calculator. So the area of one rectangle, 36.75. So one rectangle. But we want the whole shape. So there's 4 rectangles. So 4 times answer. Answer times 4. 147 centimeters squared. Question 7. Work out 13.8 times 10 to the power of 7 times 5.4 times 10 to the power of minus 12. So we're multiplying numbers in standard form. We've got a calculator, so we can just type it into the calculator. So just typing it in, 13.8 times 10 to the power of 7 times 5.4 times 10 to the power of negative 12. So just by typing this in the calculator, I've got 7.452 times 10 to the power of minus 4. But the question says, give your answer as an ordinary number. And our answer is in standard form at the moment. So we need to convert this number from standard form to an ordinary number. So this is 7.452 divided by 10 4 times. So that would give us 0.0007452. So if you divide 7.452 by 10 4 times, you get 0.0007452. You can see if you got 7.452 and divided by 10 once, twice, 3, 4 times, you get this answer. So that's our answer. A way to check the answer is to just type this 0.0007452 into the calculator, press equals, and it will convert it back to standard form. Question 8. When a drawing pin is dropped, it can land point up, point down, or point up. Lucy, Mel, and Tom each dropped the drawing pin a number of times. The table shows the number of times it landed point down and the number of times it landed point up for each person. Rachel is going to drop the drawing pin once. Whose results give her the best estimate of the probability that it will land up? So whose results are most accurate? That's the person who's dropped the pin the most times. So Mel's results give a reason for your answer. She dropped the pin the most times. Stuart is going to drop the pin twice. Use all the results in the table to work out an estimate for the probability that the drawing pin will land point up the first time and point down the second time. So all the results in the table. So we're going to do a total. So 31 plus 53 plus 16. That's 100. And 14 plus 27 plus 9 is 50. So we're going to say the probability of down is 100 out of 150. And the probability of it being up is 50 out of 150. And we can simplify these to 2/3 and 1/3. So we want the probability it will land up the first time, down the second time. So the probability of it going up is 1/3. And then we want 1/3. We want up the first time and down the second time. So it's times 1/3 times 2/3. So the probability of up and then down, 1/3 times 2/3. 1, 2 is 2. 3 3s are 9. So the probability is 2/9. Question 9. Jack bought a new boat for £12,500. The value V pounds of Jack's boat at the end of n years is given by the formula. V equals 12,500 times 0.85 to the power of n. At the end of how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? So 50% is half. So half of 12,500. So 12,500 halved is 6250. So we want to know what value of n, the lowest value of n, that gives a V of less than 6,250. So we can just type in different numbers. So say, I'll start with 1, why not? So 12,000 times 12,500 times 0.85 to the power of 1 gives £10,625. So when n is 2, I'm just going to go back into the calculator, change the 1 to a 2. That gives me 9031.25. Change it to a 3. 7,676.56. Change it to a 4. 6,525.08. That's still more, so we're going to one more time change it to a 5, and it goes down to 5546.32. So 5 years. It takes 5 years to be less than 50%. A savings account pays interest at a rate of R% per year. Jack invests 5,500 in the account for 1 year. At the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20. Work out the value of R. Okay, so we've got £79.20, and that's how much money he's got, but he's paid interest at 40% already. So this is 60% of the interest. He's only got 60% of the interest left. So 60% of the interest is £79.20. So I want to work out what all the interest was. So I'm going to change this into 100%. So what I'll do is I'll divide it by 6. Divide by 6. So I'll get 10%. So 79.2 divided by 6 is £13.20. So 10% is £13.20. So 100% of the interest must be £132. So we got £132 interest. What percent is that? So 132 out of 5500. What percentage is 132 out of 5550? So 132 over 5500, 0.024. So it's 0.024. That's as a decimal. So I'm going to times it by 100. And that will give me 2.4%. And we can check our answer. So if we do 2.4% or 0.024 times 5500, that's 132. And then times by 0.6 will be £79.20. Question 10. There are only blue counters, yellow counters, green counters, and red counters in the bag. A counter is taken at random from the bag. The table shows the probabilities of getting a blue counter, or a yellow counter, or a green counter. Work out the probability of getting a red counter. So all of these probabilities have to add up to one whole. So 0.2, 0.35, 0.4. At the moment, that adds up to 0.95. So it has to add up to one whole. So a red 1 minus 0.95 is 0.05. So the probability of a red is 0.05. Part B. What is the least possible number of counters in the bag you must give a reason for your answer. Okay, so we've got, let's write these as percentages. So we've got blue, yellow, green, red. So it's 20%, 35%, 40%, and 5%. So there's the ratio, and we want to simplify it as much as possible. So how simply can we make this? So we can divide it by 5. They're all in the 5 times table. Divide it by 5. So we've got 4, 7, 8, and 1. We can't simplify it any more than that. So this must be the fewest number of counters in the bag. The fewest must be 4 blue, 7 yellow, 8 green, and 1 red. So if we add up how many parts we've got, 4 plus 7 plus 8 plus 1, that's 20 parts. So 20 counters. You must give a reason for your answer. So if we simplified it any further, we wouldn't have whole numbers. So we need to have a whole number of counters, and the simplest we can get, if we simplified it any further, we'll have a decimal. So we need whole numbers, so that must be the fewest number of counters in the bag. Question 11. The cumulative frequency graph shows information about the weights of 60 potatoes. So we've got a cumulative frequency graph. Use the graph to find an estimate for the median weight. So we've got 60 potatoes. To find the median, we're going to look at the weight of the 30th potato. So the 30th potato is where we've got 30. So we're going to go along to the curve and then down. So that gives us 57. So that's 57 grams. Okay, part B. Jamil says 80 take away 40 is 40, so the range of the weights is 40 grams. Is he correct? Give a reason for your answer. So we've got 40 as the lowest, 80 as the highest, but the cumulative frequency graph would have been drawn with grouped data. So we don't actually know if there was a potato that actually weighed 80 grams. The highest could have been 76 or 77. So in the 70, we know there were potatoes in the 70 to 80 group, if that was the group, but we don't know the actual weights of the potatoes. So is he correct? You must give a reason for your answer. So if a cumulative frequency graph is drawn with group data, which they usually are, we don't know the actual weights so the highest weight could have been less than 80. Part C, show that less than 25% of the potatoes have a weight greater than 65. So if we go to a weight of 65, Go up to the line, then along. So that comes out as 49. So show that less than 25% have a weight greater than 65. So there's 49 below, so there's 11 above. So 60 minus 49 is 11. So 11 potatoes have a weight greater than 65 grams. 11 over 60 times 100. So 11 60ths times 100 comes out as 18.3%. So that's less than 25% because it's 18.3%. Question 12. Alan has two spinners, spinner A and spinner B. Each spinner can only land on red or white. The probability that spinner A lands on red is 0.25. The probability spinner B lands on red is 0.6. So we've got all that information on the diagram. Alan spins spinner A once and spinner B once, again on the diagram. He does this a number of times. The number of times both spinners lands on red is 24. So the probability of that, so probability of red, when we go across the branches we times. So 0.25 times 0.6 is 3 over 20 or 0.15. All right, 0.15. So that was 0.25 times 0.6. So red, probability 0.15. So that's 24 times. So 24 times equals 0.15. I'll just write that down. What's the question? Work out an estimate for the number of times both spinners land on white. So white, let's do that probability. So 0.75 times 0.4. So that's going to give us 0.3. Okay, that's a nice number. So if 24 times, if it lands 24 times with a probability of 0.15, how many times will it land for a probability of 0.3? So this is twice as much. So this should be twice as much as well. So we would expect it to land 48 times. Both spinners land on white, yep, 48 times. Question 13. Write x squared plus 6x minus 7 in the form x plus a squared plus b, where a and b are integers. So we're completing the square. So we're going to half the middle number, half the b number. So we're going to have x plus 3 squared. Then we're going to take away 3 squared. So take away 9. And we've still got the minus 7 on the end. So we've got x plus 3 squared minus 16. So x plus 3 squared minus 16. If we expanded the brackets, took off 16, that will get us back to what we started with. So x plus 3 squared minus 16. Question 14. Cone A and cone B are mathematically similar. The ratio of the volume of cone A to the volume of cone B is 27 to 8. The surface area of cone A is 297 centimeters squared. Show the surface area of cone B is 132. So we've got the ratio for volumes So ratio for volumes, 27 to 8. So that's the scale factor cubed. So the ratio for lengths is going to be the cube root of these. So cube root 27 and cube root 8. So that's the ratio for lengths. So the ratio for areas is scale factor squared. So this is the scale factor. We're going to square it. So 9 to 4. So scale factor for length squared makes area. Scale factor for length cubed is the scale factor for volume. So the surface area, we're going to use the areas one. This is our scale factor for this question because we're in areas. So the surface area of cone A is 297, and we want to know the surface area of cone B. So what do you times 9 by to get to 297? So let's do 297 over 9, and that's 33. So we're going to times by 33 here, which means we must times by 33 on this side. So 4 33s, and that's 132, and we knew it was because they gave us the answer in the question. Question 15. So part A, show that the equation x cubed plus 7x minus 5 equals 0 has a solution between 0 and 1. So we're going to substitute in 0. We're going to substitute in 1. So we've got, if we substitute in 0, we get negative 5. If we substitute in 1, we get 3. So we've got a change of sign. We had a negative to a positive. So change of sign. Therefore, solution between 0 and 1. Part B, show that the equation, the same equation, can be rearranged to give x equals 5 over x squared plus 7. So we need to rearrange this to make this. So if we plus 5 to both sides first, equals 5, and then factorize out the x. So x times x squared makes x cubed, x times 7 makes 7x, and then divide by x squared plus 7. And part C. So starting with x0 equals 1, use the iteration formula 3 times to find an estimate for the solution of the same equation we started with. So we're going to start with 1. So we're going to find x1 by substituting 1 in to our iteration formula. So that'd be 5 over 1 squared plus 7. So 5 over 1 squared plus 7. So we're going to type it into the calculator. And that gives us 5/8 or 0.625. And then to find x2, we're going to substitute our 0.625 into the formula. So 5 over answer. We're going to use the answer button on the calculator. Squared plus 7. So where I had 1 before, I'm going to change that to ANS. So that gives me 0.6765327696, and then x3. So this time we're going to substitute the 0.676532 and so on in. But I'm just going to press the equals button again, and that gives me 0.6704483001. So we've done it 3 times. So our estimate for the solution is 0.67044830 and so on. By substituting your answer to part C into x cubed plus 7x minus 5, comment on the accuracy of your solution. So I've still got that in my calculator, so I can use the answer button again. Answer cubed plus 7 answers minus 5. So answer cubed plus 7 answer minus 5, and that gives me minus 5.49 times 10 to the power of minus 3. So comment on the accuracy of your estimate. Well, it's very close to 0, so because that is 0.005, so it is close to 0. Therefore, quite accurate. Question 16. The petrol consumption of a car in litres per 100 kilometers is given by the formula. So we've got petrol consumption equals 100 times number of litres of petrol used divided by number of kilometers travelled. So Nathan's car travelled 146 kilometers to 3 significant figures and used 11.8 litres, also correct to 3 significant figures. So we've got a bounds question here, haven't we? Nathan says, my car used less than 8 litres of petrol per 100 kilometers. Could he be wrong? So we want the upper bound. We want to know the most it could have used. So for the upper bound of petrol consumption will be 100 times the upper bound for litres divided by the lower bound for kilometres. So the upper bound is the biggest number possible divided by the smallest number possible. That will give us the biggest answer. So let's get these bounds. So for kilometres, we've got 148. The one up's 149. The one below is 147. So the bounds are 147.5 and 148.5. And for litres, we've got 11.8. The one up's 11.9. The one below is 11.7. So we've got 11.75 and 11.85. So we want upper bound petrol consumption. Upper bound of petrol consumption is 100 times the upper litres, 11.85 over the lower kilometers, 147.5. So we're going to type it into the calculator. And we get out 8.03. 8.03 liters per 100 kilometers. So could Nathan be wrong? Yes, he could. So yes, because it's 8.03 is the upper bound, which is above 8. Question 17. ABC and ADC are triangles. They're shown in the diagram. The area of triangle ADC, that's the bottom one, is 56 meters squared. So the bottom triangle is an area of 56 meters squared. Work out the length of AB. So A to B is in the top triangle. Give your answer correct to 1 decimal place. So we're going to have to use the information we're given in the bottom triangle to find the common length of the two triangles, this one here, and then we'll use that to work out x. So we're going to work with the bottom triangle to start with, and we've been given the area, so we can work out another length using area equals half AB sine C. So half AB sine C is, we've got the angle in between the two sides. So if this is big C, the two next to it are A and B, lengths A and B. So we're going to work out, I'll call it Y, this one. So we're going to work out this length here first. So area 56 is half A and B, they're 11 and Y. So half times 11 times Y, sine angle 105. So if we do half times 11 first, that's 5.5 times Y times sine 105. So to get Y by itself, we're going to divide by 5.5 and sine 105. So we're dividing by 5.5 sine 105. So Y is 56 over 5.5 sine 105. So 56 in the calculator over 5.5 sine 105. And that gives me 10.54099,384 and so on. So this is Y. That's our Y. I'm gonna store it in the calculator. It will save me typing out the whole number again. So now I've got enough information to find this common side, this green side. So I'm going to call that Z. We'll call that Z. So we can use the cosine rule now, because we know this angle and the two lengths opposite it. We want to find the third length. That's the cosine rule. So A squared equals B squared plus C squared minus 2BC cos A. So if this is big A now, the 105 is big A, that makes the Z the little a. So we've got Z squared is 11 squared plus, I'm going to do answer squared, I've still got that answer in the calculator, answer squared minus 211 answer cos 105. So I can type this whole side in the calculator in one go, which is what I'm going to do now. So 11 squared plus answer squared minus 2 bracket 11 bracket answer cos 105. So that gives me z squared of 292.133 and so on. I'm going to square root that answer, which gives me z of 17.09190364. I'm going to keep that in the calculator as well. And now we can move on to working out x. So now we've got opposites, which makes it the sine rule. So I'm working out x. So I'm going to put the lengths on top. So I'm going to have a over sine A equals b over sine b. So a, so we're going to have x over sine 48. The opposites go together. X over sine 48 equals b, which is answer, still in the calculator, answer over sine 118 and to get x by itself, I'm going to times both sides by sine 48. So that will be answer over sine 118 times sine 48. So I'm going to type this in the calculator now. Answer over sine 118 times sine 48. And that gives me 14.4, and that's centimeters to 1 decimal place. Meters. So 14.4 meters to 1 decimal place. Question 18. Here is a speed time graph for a train. So there's a nice speed time graph. Work out an estimate for the distance travelled in the first 20 seconds. Use 4 strips of equal width. So the area, we want the area under the graph. So distance travelled is area under the graph. So we're working out an estimate of the area underneath the graph in the first 20 seconds. So the area under this part of the graph, and we're doing it by getting 4 strips. So we're going to go up, so we're cutting it into 4 strips, and we're just going to join them up with straight lines. So we're going to join the strips up with straight lines, and that's why it's an estimate, because they're straight lines. It's not the actual area under the curve. It's close to it, but they are straight lines, not the curve. So it's an estimate. So we're going to work out the area of each of these strips and then add them together for the total area. So we've got a triangle here. Base is 5. So let's work out all the side lengths first. So all the bases are 5 for all of these shapes. And then this line here. So be careful of the scale up the side. Each 2 boxes makes 1. So this is 2 tool. We've got 5 tool here. That's 10 tool. and this is 15, 16, 17, 18 till the last one. So we're going to work out the area of each of these strips. So the first one, we've got half base times height. So half times 5 times 2, which is 5 for the first strip. The second one, we can either cut it into a rectangle and a triangle, or do it as a trapezium. So if we've got a trapezium, it's half times the sum of the two parallel sides, so 2 plus 5, times the distance between them, which is 5. That is, well, we'll type it in the calculator. That's 17.5. Then the same for the next one, so we've got half 5 plus 10 times 5. That's 37.5. And finally, half 10 plus 18 times 5. And that's 70. So we're going to add them all up. So 5 plus 17.5 plus 37.5 plus 70 and that's 130 meters. Part B. Is your answer to A an underestimate or an overestimate of the actual distance? So if you look at the trapeziums we've drawn, the triangle and the trapeziums we've drawn, they go over the actual curve. So the area I've worked out is bigger. So it's an overestimate because the trapeziums go over the curve. The actual area under the curve is less. So it is an overestimate as the trapeziums, or the straight lines I've drawn, either of those, go above the actual curve. So the trapeziums, the area under the trapeziums is more than the area under the curve because they go above the line. Question 19. Prove algebraically that the straight line with equation x minus 2y equals 10 is a tangent to the circle with equation x squared plus y squared equals 20. So what does this mean? So we've got a circle. And a tangent, which is a straight line. So if it's a tangent, that means it just touches the circle once. So if it's a tangent, then the simultaneous equations will have one solution. So a tangent, it only touches once. It will have one solution. If it passed through the circle, it will have two solutions because it will have a point of intersection here and here. So it will have 2 points if it went through the circle. If it's a tangent, it's only got one solution. So we've got simultaneous equations and they should only have one solution. So all we've got to do is solve the simultaneous equations and show they've got one solution. So we've got x squared plus y squared equals 20 and x minus 2y equals 10. So I'm going to rearrange our linear equation to make it either x equals or y equals, and then substitute it in. So I'm going to plus 2y to both sides. So I'll have x equals 10 plus 2y. So then I'm going to take x equals, so 10 plus 2y, and I'm going to substitute it in for x. I'm going to change x in this equation to 10 plus 2y. So that will give me 10 plus 2y squared plus y squared equals 20. So 10 plus 2y squared, I'm going to write that as two separate brackets. So 10 plus 2y, 10 plus 2y plus y squared equals 20. I'm going to expand those brackets now. So 10 tens are 100. 10 times 2y is 20y. 2y times 10 is also 20y. 2y times 2y is 4y squared plus another y squared equals 20. I'm going to collect the like terms now. So I'll do the y squareds first. 4 of them plus 1 of them is 5 of them. 5y squareds. The y's, I've got 20 plus 20, so that's 40. And I've got 100 left equals 20. Now I want to, well, it's a quadratic, so to solve it I need to make it equal to 0. So I'm going to subtract 20 from both sides, which gives me 80 left. Now I want to solve it. I'm going to simplify it first. So all of these numbers in the 5 times table. So I'm going to divide the whole equation by 5. So that will give me y squared plus 8y plus 16 equals 0. Now it's a lot easier to factorize. I can factorize this. I'm going to put it in 2 brackets. What multiplies to make 16 and adds to make 8? 4 and 4. So y equals -4. You see it's only got one solution because both brackets are -4. So y equals -4. What's x? X equals 10 plus 2y. So x equals 10 plus 2y. So 10 plus 2 -4s, which is 10 minus 8, which is 2. So there's only one solution. So we've got one solution. So the linear one, so it's a tangent. I just put it is a tangent. And I put at 2 minus 4. Question 20. A, B, and C are points on the circumference of a circle, center O, which we can see. AOB is the diameter, so it goes through the center. We've got that. Prove that ACB is 90 degrees. You must not use any circle theorems in your proof. Okay, we're not allowed to use any circle theorems. So what we're going to do, we're going to connect the center to point C, or as close to as possible. So we're connecting the center to point C. And then we're going to take let's just call an angle X. So I'm going to have X as AOC, and I'm going to have Y as BOC. So I've got X as AOC, Y as BOC, and they're on a straight line. So I'm going to write down x plus y are equal to 180 degrees because angles on a straight line add to 180. Okay, so what shapes have I made here? By drawing this line, I have made this isosceles triangle. So the two angles at the base of an isosceles triangle are equal. So these two green angles here must be, so I'll put an arrow, it must be 180, take away x over 2. So the whole triangle is 180 degrees. If you take off the angle you've got already, which is x, and half it, that must be both of these two green angles. So the green angles are 180 minus x over 2. And we can do the same for the y's. So I'll just put the reason here as well. Angles at the base of an isosceles triangle are equal. And we can do the same for the y. So we've got another isosceles triangle over here. These are all radiuses, that's why it's isosceles. So the two angles at the base of this triangle have to be 180, take away y over 2. So that's 180 take away y over 2. And this is 180 take away x over 2. So our angle ACB, we can write down what it is in terms of x and y now. ACB is 180 minus x over 2 plus 180 minus y over 2. So it's the green angle plus the purple angle. And I'm just going to simplify this. So I'm going to divide through by a half. So 180 over 2 is 90. And x over 2 is half of x. So 180 minus half x plus 180 over 2 again is 90. And y over 2 is half of y. And I can collect the like terms. So 90 and 90. That's 180. And I've got minus half an x minus half a y. And now I'm going to factorize out the minus a half. So I've got 180 minus a half of x plus y. So ACB is 180 minus a half of x plus y. But remember, x plus y is 180 degrees. So I'm going to change x plus y into 180 degrees. So I've got 180 minus a half of 180, which is 180 minus 90, and that is 90 degrees. So we've proved that ACB is 90 degrees. Okay, question 21. OAN, OMB and APB, they're all straight lines. We've got 3 straight lines. They're shown in the diagram. AN equals 2O to A's. So A to N is 2O to A's. M is the midpoint of OB, and O to A is A. So O to A is called A. And remember, AN is two of those. So A to N must be two A's. So I'll add that one in as well. O to B is called B. So the whole way across is a B. And M is halfway. So I'm actually going to write half B, O to M, and another half B, M to B. A to P is K times K of A to B. So A to P is a fraction times A to B. That's obvious. A to P, no, we've done that one. Given that MPN, this here is a straight line. MPN is a straight line. Find the value of K. Okay, so what can we work out? We can work out A to B. So A to B. How do I get from A to B? I can't go down here. I don't know the root. So I'm going to go minus A plus a B. So A to B is minus A plus B. And that means that A to P is K times this. So K times A to B, K times minus A plus B. Okay, so there's A to P. That's what we're working out. We're working out K. Given that MPN is a straight line. So MPN is a straight line. So we can work out M to N, or N to M, or M to N, either one. So if I say, does it make a difference? Probably not. I'll go N to M. So N to M is, so we've got minus 2A minus A, so minus 3A plus half a B. So there's N to M, and we know N to P must be a fraction of that, because they're on the same straight line, which means they go in the same direction, just by a different amount. So N to P must be a fraction. Let's call it, can't use K, I'll use X. N to P is X times minus 3A plus a half B. So N to P is a fraction of minus 3A plus half B. And N to P is also, so if I went from N to P is also minus 2A. So if I went from, oh, it's N to A and A to P. So N to P is minus 2A plus A to P, which is K, which I'll put here, K times minus A plus B. So I've got two different expressions for N to P, two different things for it. So these are both N to P, so they must be equal. So I'm going to write down X times minus 3A plus half B must be equal to minus 2A plus K times minus A plus B. And to solve this, I'm going to separate the A's and the B's. So I'm going to say the A's must be equal and the B's must be equal. So I'm going to rearrange it slightly. So I've just got one expression for A and one for B separately. So I'm going to expand these brackets first. So I'm going to have minus 3x A plus half x B, and I'll have minus 2a plus, no, I'll have minus 2a minus ka plus kb, and I'm going to change that again. So I'm going to say I've got minus 2 minus ka plus kb. So we've got the a's must be equal, the a's must be equal, and the b's must be equal. So if I separate out a's and b's, so on the left side I've got minus 3xa, so I've got minus 3x, and here I've got minus 2 minus k. So minus 3x must be equal to minus 2 minus k. The a's must be the same, and the b's must be the same. So half x must be equal to k. So half x equals k, and minus 3x equals minus 2 minus k. If I want x equals here, I'm going to double, so x equals 2k, double both sides, and then I'm going to substitute 2k in for x. So substituting 2k in for x, I've got minus 3 times 2k equals minus 2 minus k. So minus 6k is minus 2 minus k. I'm going to plus k to both sides. Am I? No. I'll plus 2 to both sides. Plus 2 equals negative k. And then I'll plus 6k to both sides. So that'll be 5. 2 equals 5k. Divide both sides by 5. So k equals 2/5.